Hello everyone and welcome to the new section where we will discuss about Google Cloud DevOps services. So let's have a look at the learning objective of this video. As obvious, we are going to start with the overview of developer tools and DevOps services, cloud source repositories. After that we'll move to cloud build, then container registry, IDE integration, and after that we'll have a demo for storing a Docker image into container registry. And finally, we'll wrap up the section with the discussion around use case of developer tools and DevOps services. So let's get started. So before moving further, if you are now subscribed to the channel, I request you to please subscribe. So the overview of GCP DevOps services. So DevOps services provide tool and framework for automation. So if you are a developer or a DevOps engineer and you are looking for automation and getting the things quickly done, then you should go for GCP DevOps services. All right. So what all things it has to offer to the developers and the DevOps engineers, we'll see in this section. So the cloud source repository store and track source code. So this cloud source repository, basically it's like a GitHub or GitLab. This is the one that Google provides for storing your source code and tracking it. If you already know GitHub and GitLab, you will be able to understand these cloud source repositories. Now the cloud build automates continuous integration and deployment. So it's the CI/CD pipeline that is provided by GCP basically to do the continuous integration and deployment. It can also be integrated with third-party tools like GitHub or GitLab for taking the build from there and starts its deployment. It's similar to Jenkins. So the container registry acts as the central repository for storing, securing, and managing Docker container images. So if you have a microservice and you have a container images, then it acts as a repository where you can store all your Docker images and other artifacts and manage these containers for deploying from this location. All right. And IDE and the tool integration enables developer productivity. So it also provides us the IDE and the tool integration so that the developers can integrate their application with the IDE for better management and deployment using this IDE. So that's the overview of DevOps tools. And now let's look at them one by one. So the next one is cloud source repositories. So it acts as a scalable private Git repository where you can store your code and all the developers and DevOps team can make use of it. So it extends standard Git workflow to cloud build, cloud PubSub, compute services. So the idea here is that your source code, when you are using the cloud source repository, will be close to the GCP environment. All right. So it will use the same network services that other GCP applications are using, and your source code is in the same environment. So if you want to deploy your code, it will be using the same network. So build, deploy, and perform all the CI/CD pipeline activities. So it will be having low latency and the processing will be very faster because everything is in single network, right? Now unlimited private Git repositories that can mirror code from GitHub and Bitbucket. So it provides you unlimited private code, that is you can secure your code, it will not be public and it's unlimited, and you can also mirror your code from the GitHub and Bitbucket. So you can replicate the GitHub code and Bitbucket code in your cloud source repository, right? It triggers automatically build, test, and deploy your code. So there is a trigger whenever you push your code to cloud source repositories, it triggers build, test, and deploy. Now you can enable this trigger or disable it based on your requirement. All right. It's integrated regular expression based code search. So if you have a large database of code, you can use that regular expression for searching a particular file or a particular line of code. All right. It's a single source of code for deployment across GCE, GAE, GKE, and Google Cloud Functions. So if you are using this cloud source repository, you can deploy your code anywhere in the GCP cloud. It may be Compute Engine or App Engine or Kubernetes Engine or Google Functions. All right. So let's now have a look at the Google Cloud Build. So it's a managed service for source code build management. Means that once you complete your code, you need to deploy it somewhere, right? So in order to deploy it, you need to build your code, right? So Cloud Build is a CI/CD tool, that is continuous integration and continuous deployment tool, that will manage all your build process. You don't have to do certain operations in order to deploy your code. Let's have a look at the example in here. Let's assume that these boxes are the steps that are involved in deploying your code. Alright, so let's say that the first one is for pulling your code from Bitbucket or Google Cloud Source Repository or anywhere where your source code is located. Alright, and the next step in the deployment is the quality check, where it runs certain kind of checks to find any issues with your code. The next step can be the test, basically running your unit test cases. The next step can be dockerizing your code, building the image for your code, and finally it will be deploying your code. All right, so the cloud build says that don't do all these steps manually. Instead, you make a pipeline where I will perform all these codes for whatever environment you provide and for whatever code you provide. All right, so let's say that you want to deploy your code in the QA environment. So you provide the URL of your source repository along with the branch information, and you trigger with the button. It will just take the latest code from that branch and it will start quality check and perform all these steps, and it will be finally deploying it. So you have to write a one-time script for quality check, for testing, for dockerizing, and all those things will be taken care from the next time. So if you have a very frequent release cycle, let's say 1 week or 2 weeks, so you don't have to perform all these steps. It will save a lots of effort for the developers as well as the DevOps team. All right. So it supports building software written in any language. It doesn't matter whether your code is Java or Python or any other language. You have to just provide the source code location and it will deploy by following all these steps. It's a custom workflow to deploy across multiple target environments. Now you wanted to deploy that code for a QA environment. Similarly, you can deploy your code in the dev environment or in the prod environment. And similarly, you can deploy your code in any target environment, let it be GCE or GKE or even on the cloud functions. All right. It's tightly integrated with the cloud source repo, GitHub, and Bitbucket. So you can give the URL of even a cloud source repo, Bitbucket, and GitHub. It will start taking your code from there and doing the build. It supports native Docker integration with automated deployment to Kubernetes and GKE. So it supports Dockerization, where you give your code, it will build the Docker image, it will take the backup of that Docker image into some kind of repository, and you can perform the Docker tags and Docker build as well using this cloud build. Identifies vulnerabilities through efficient OS package scanning. So as I mentioned, there is quality check in here. It will be checking for all the issues that comes in. It will be performing certain kind of task, and if it finds any kind of issues, it will not let the code move forward to the next step. It will fail here itself. You have to go back and check the logs in order to identify what failed. All right. So this is all about Google Cloud Build. Now let's have a look at Container Registry. It's a single location to manage container images and repositories. So you already know what is a repository, where you store all your artifacts or jars or anything that is important for your project, right? So Container Registry basically stores the container images, all right, or the Docker images in one place. Why it stores it? As in the previous slide we saw, there was a step where the Docker was involved. When your code is coming through the pipeline, it comes to Docker, it forms a Docker image and it stores it in a container registry. The next step will take the image from that registry and start performing the build on that image. All right. So it stores all the images that you are making using the pipeline. It stores images close to the GCE, GKE, and Kubernetes cluster. So whether your application is running on GCE or GKE, it will be storing in the same network where your code is being deployed. All right, so that it will increase the performance of your application and it will not be having any lags. It's a secure, private, scalable Docker registry within GCP. So the person who is having only access to this container registry can access. So it's a secure and private. And you can store any number of images. It can be scaled up in the memory as well. Now it supports RBAC, that is role based access control, to view, access, and download the images. So it's very much secure. It uses the IAM policy for role-based access control. Detects vulnerabilities in early stage of the software deployment. So once your image comes in here, there is a background check that is performed on this particular image, and if it is vulnerable, it will be marked as red and it will not be provided in the next step, or it cannot be moved to the production. It will be locked out. So supports automatic lockdown of the vulnerable container images. So if it finds any vulnerability, it will be locked down. Automated container build process based on code or tag changes. So whenever there is a change in the code, it will be building the image, or whenever you change the tag of a particular image, it will automatically detect it and start the build process. All right, so that's all about container registry. So now it's time for us to learn about developer tools. So developer tool is a IDE plugin for popular development tools like IntelliJ, Visual Studio, Eclipse, and so on. So you can use the developer tools in these plugins for making your task more simpler. Developer tool has a tight integration between the IDE and the managed source code management systems and the build services. So when you install this plugin in your Eclipse, you will be able to push your code or pull the code or even trigger the build from your IDE itself. Automates generating configuration files and deployment scripts. In order to deploy and build your file, you will need the configuration files and the deployment scripts, Docker scripts and similar other scripts are there. So it will automate all those manual activity when you use this developer tools. It makes GCP libraries and SDK available within IDE. So whenever you want to integrate any Google services, you will need the libraries, right? And the SDKs. So this plugin basically it will pull the libraries that are required for integrating that particular tool or application. It enhances the developer productivity, so you don't have to run here and there for getting the libraries or for making the deployment script or download the git patch for pulling and pushing your code. All these things are taken care by this developer tool, so that enhances the productivity of developer. All right, let's have a demo on container registry. So in this demo we will be storing a Docker image in the container registry. So what we'll do, we'll get an image, a Docker image basically. Then we will make some changes in that image, and after that we will push that image on the container registry. So let's go to our Google Cloud Console. So we are on our Google Cloud Console and let's search for container registry. So it's here, container registry, and if you see here, you can see the images tag here, and there are no images currently, that's why this is empty. Now we are going to run some set of commands on the Cloud Shell so that we can get the image, make some changes in the image, and then we can push that image on the container registry console. Okay, so let me open up the Cloud Shell. So the Cloud Shell is started. Let's have a look at the commands that we are going to run in the Cloud Shell. First of all, we'll run this command: gcloud service enable registry Google registry Google APIs.com. This will enable the container registry of the Google APIs. Okay. After that, we will declare a variable, basically the project ID, And in this project ID, we will replace this with our project. In my case, the project ID is technotab. Don't forget to replace it. Then we will do a docker pull busybox. Actually, busybox is a very small container image that is having all the utilities of the Unix. We don't have to bother about what's inside this busybox. We just have to know that it's a container image that we have to pull, and then this command docker images command is used to display the images. After that, we will create a file, the docker file, and in that docker file we will have only this text, that is latest cmd date, that will display the date. So if we don't have the docker file, our docker image will not be built. Okay, and this command is used for building it. The docker tag command is used for tagging that image, basically with the name that you extend here. Docker run is used for running that image. After that, we will authorize that configure docker, so that it takes our Google credentials for configuring the docker, and after that we will push the image. So these are all the steps that we are going to perform. Let's start with the first command. Go to the cloud shell, just type the command, and this will enable your container registry. So it has enabled. Now next is the export project ID. This project ID, let me give my project ID here. If you don't know where you get the project ID, you can just click on this project, and you can say this name of the project, and you see the ID, right? So you have to give this ID, enter. This is just, we have created a variable project ID that is storing our project ID. Let's go to the next command, that is docker pull busybox. So basically this will pull the busybox image. Okay, and you can see the image by using the command docker images, and these are the list of images that will be shown. You will be getting only one image, that is this busybox image. I had some other images already there, that's why it is listed here. We can see that this busybox image is listed here. Let me go ahead and create this file, docker file. Click enter, and this file will be created, and this docker file will be having busybox latest and the cmd date. You can also go inside this docker file and check what is the content of it by giving the command vim docker file. Okay, so here I have run the command for 2 times. Before also I had run this, so that's why it is coming for 2 times. Let me delete it, the previous one. And for saving the file, just click on colon wq exclamation enter. Now it's time for us to build the image. So this command is for building the image. Basically I'm building with the name my busybox. The build is successful. Now we are going to tag this image with different name, that is docker tag. With this particular name we are going to tag it. Tagging is done. Now we are going to run this image, and if we run this, it will print the date and time, because in the docker file we have that date and time. Okay, now we will use this command auth configure docker. This will be internally already done. To confirm that if you are not already configured, you can run this command. Here you can see that gcloud credential helper already registered correctly, right? And after that we will give the final command, that is docker push and the latest image that we have created. So the image is pushed, and if you come down here and refresh this page or click on the image, you will be able to see image in here. And this image you can pull it from anywhere from your pods. You can go and run this image, or you can export this image to anywhere you want, right? So that was a very comprehensive demo, and in this demo we learned that how we can register any image in the container registry. All right, so let's move to the next section, that is use cases of Google Cloud DevOps services. So the Google Cloud source repository, so that is basically a private source code repository where you store your code securely in the cloud, and the service type is SCM, that is source code management, just like Git Bash and Bitbucket. The next is Google Cloud Build, that is basically used for build and deploying your code. It's similar to Jenkins, where you provide your source code and it will perform all the deployment activity. So it's a pipeline to deploy code automatically from source code. Okay, and we call it as a CI/CD, continuous integration and continuous deployment. The Google Cloud Registry service basically acts as a repository which stores private image close to your compute services. So it will be using the same network where your code is being deployed, and it will be very fast. Stores the image in the same region as GKE cluster, and it's a private container registry. Now the IDE integration, basically it's a developer tool. This is the plugin that you have to use in order to increase the developer productivity by manage and deploy apps just from the IDE, that is IntelliJ or Eclipse or Visual Studio. So that completes the section on DevOps services. So if you learned something from this video today, I request you to please like it and provide your valuable feedback in the comment. And if you are not subscribed to the channel, I request you to please subscribe it. It's totally free of cost. You are not going to lose something, but it will give me the motivation to make more such videos like this. So with that, I complete this section here, and thanks for watching. See you in the next video.